Hi, this video discuss about general steps in feature engineering and feature engineering outlier handling steps and how to handle the features in feature engineering. First one, data preparation. That means the raw data which is collected from the environment to be transforming into the suitable format that can be used for our designing machine learning model. This process may includes data cleaning, that is we are going to removing the unwanted irrelevant features, and also we can extract the features from the images. So this process will be done in data cleaning and data augmentation here, which is useful to increase your the size of input data set. Then fusion, which is useful to combining the different features into make as one feature. And also ingestion. Then second one, exploratory analysis. Exploratory analysis used to explore more knowledge from the given data set, which is useful to analyze the data set and investing the data set, and you can get more summarization about your characteristics of data set. So this process, exploratory analysis, can be done by using visualization techniques and visualization tools to make better understand about the manipulation of data sources, which is useful to select best relevant features which are contributing to our designing machine learning model. So when you are selecting the best features to contribute our model, then it can be very useful to increase our accuracy of our model. Third one, a benchmark. When we are designing the machine learning model, we have to take any benchmark data the to compare our model. So the benchmarking is a process of setting a standard baseline for accuracy to compare all the variables from this baseline. So when we are designing the machine learning classifier, that classifier has to be compared with already existing standard classifier to compare the accuracy of that existing standard classifier and our machine learning classifier. So that can be useful to improve the accuracy of our designing machine learning model and reduce the error rate. The feature engineering is having some of the techniques to handle the features. First one is imputation, second one handling outliers, log transformation, binning or discretization, feature split, and one hot encoding. Another one is scaling. Here the feature engineering is mainly deals with irrelevant data, missing values, human interruption, general errors, and insufficient data sources. Here, the first one is imputation. Imputation is used to handle the missing values in the data set. So, missing values in the sense you look at the given data set. Here, the first sample is not having the second feature value. So this is NaN means the value is not available, not a number. NaN means not a number. So this value is missing in the feature number 2 of sample 0. Likewise, the second sample is not having two values for the feature C and feature D respectively. And third data point is not having value for the feature A and feature D. So these are called missing values in the given data set. If the values are missing, then contribution of these values to our model is not available. If these values are not contributing to our model, then performance of our designing ML model will be decreasing. So to avoid that, we can use numerical imputation and categorical imputation. So these two methods will be used to handle the missing values. First, we will see the numerical data imputation. So the numerical data imputation is handling the numerical values. The default value can be imputed. Imputed means added into the column where missing values are filled. Okay, the missing values are filled with mean of that feature values or median of that feature values. For example, in this given data set, the height variable is missing the value and weight variable is also missing the values. So here we have to fill this missed values. Here this is categorical value and weight is numerical values. The numerical values can be filled with by taking mean of this feature values or median of this feature values. So this is filled with median of this feature values, median of this feature values. Okay, likewise for categorical values you can take maximum number of occurrence of the feature value. Here no is appearing two times, x is appearing one time. So the no is appearing more than the yes. So we can fill that missing value with no. So this is called mode. This is called mode. So the missing values can be filled by using mean and median for the numerical values. You can apply the statistical procedure mode for the filling of categorical values. Then handling outliers. What is the outlier? The outlier is which the outlier data point will behave differently than the other data points. You look at here, we are having so many data points here. These are the data points available in the plot. So in this given data points, these data points are behaving similarly, but this single data point is behaving in different manner. So how do we identify that? This different behavior data point is called outlier. That means which is available out of the another data points, far away from the far away from other data points. So this single data point is far away from another data points. That is the meaning of this one. Second plot, look at here. Here all the data points are close to each other, but single data point is far away from other data points. This far away data point from other data point is called outlier. The data points which is far away from other data point is called outlier. So what is the disadvantage of this outlier, how it is affecting our model, that we will see now. So outliers are deviated values or data points that are observed too away from other data points. This is affecting the performance of our machine learning model. The feature engineering technique first identify the outliers and remove the identified outliers from our data set. However, the removal leads to loss of some samples. Yes, suppose if you are having 10 data points, then from the 10 data points, if you are having one data point is outlier, if we remove this, then we are losing one data point from our out of 10 data points, so we will have only 9 data points. So we will lose some of the data samples if that outlier, if that consider as a outliers. So how to handle that outliers? First process is identifying the outliers. So for identifying the outliers, we are having two methods. One is the sorting method and the second one is data visualization method. In data visualization method, we are having a standard methods jet score and interquartile range method. Here the how to identify the outliers using sorting method. The given data set will be sorting out using ascending order or descending order, right? When you're sorting out the data point which is appearing in the last, you see the range of this data points between 1 to 10, right? Here also range of data point is 1 to 10, but this data is appearing entirely different value. So when you are sorting out this data using ascending order or descending order, this will appear in the last or first row of the data set. So this will be considered as outlier in the given data set. So here you see in this plot we are having set of data. For this data we are drawing the regression line. So this regression line is always give you the relationship between input variables and output variables. Here this group is each data point near to each other, but this data point is far away from this data point. So this data point is called outlier, even though this is locating on the regression line. For this regression problem, this outlier is not affecting. But in the second plot, the data point is available here. This is outlier because which is far away from the existing other data points. Okay, so this regression line is plotting towards the data point outlier. So but which regression line, actual regression line should be like this, because our more data is available here. Because of single data, our regression line is varying from this location to this location, so which is affecting our regression model. So the outlier, some of the outlier will affect the machine learning models performance. Some of the outliers may not affecting. So whichever outliers are affecting our model, that can be removed or transformed the from the data set. And second method is visualization method. In visualization method, first one is jet score method. So jet score method is based upon the Gaussian distribution, which is detecting the outliers when variables distribution looks close to Gaussian distribution. The Z score is number of standard deviations value of a variable is away from the mean variable. The formula for the Z score is Z equal to the data point value x minus mean of that features and standard deviation. So here the mean is the center point of the bell curve. Here the z score is 0, then both sides the data is distributed based upon the z score value. So here this this portion is z score 1, then minus 1. This portion is z score plus 1, then this portion is z score plus 2. This portion is z score minus 2. So this portion is z score plus 3. This portion is z score minus 3. Standard by standard values we will use z equal to minus 3 and z equal to 3. So whichever data points available within the three scales within the three scales these values are these data points are contributing to our model. If the data points are available out of this three scale, so these data points are called outliers by using the z score. Second one, in data visualization method, interquartile range. In interquartile range is providing range of middle half of the data set, which is useful to create bound around the data and then define outliers as any values that fall outside that bounds. First of all, we have to sort the data from low to high, then identify the first quartile. You look at this diagram. First, we have to find out first quartile. First quartile is 25%. First 25 percentage of data. Then quartile 1 to median. Median is 50%. 50%. Then quartile 3 is 75%. Then this one is 100%. 100%. Okay, so now we found four quartiles. Here quartile 1 median, quartile 3, then quartile 4. So here we have to calculate upper bound and lower bound. Upper bound we have to use quartile 3 value plus 1.5 into interquartile range. Interquartile range is calculated quartile 3 value minus quartile 1 value. Then we can calculate lower bound. So based upon this the data points available here which are contributing to our model, the data points which are available out of this lower bound and out of this upper bound, the data points are available out of the upper bound, these two data points available out of the lower bound, these data points are called outliers. So in this manner we can identify the outliers. So the outliers can be identified by using two methods. One is sorting method and another one is data visualization method. Data visualization method is having two methods. One is z score and another one is interquartile range. Then third one is logarithmic transformation. Here which is mathematical function which is used to transform the values from one range into another range by using the logarithmic mathematical function which is handling the skewed data. So when you are applying the logarithmic transformation, the distribution becomes more approximate to normal after the transformation. The magnitude order of the data change into within the range of data. The value of that order. For example, some data samples may have here the value, here feature 1, feature 2, feature 3, here label. Here this feature 1 may have 1000, here it is 5000, here 2, here feature 2 may have 500, then 220, then 10. So when you are having the values like this, so different scales are there. So you can apply the log of 1000, that value will log of 1000, log of 5000, log of 2. Then the highest range will be transforming into the lowest range. So you are you are going to reduce the range into smallest range, so you can reduce the computational power. That is the main thing. And whenever uh, we are using this, it can identify the identify the outliers, and the outliers value will be decreasing within the range by applying the logarithmic transformation. This transformation must have only the positive values, otherwise we will get the error. So it cannot apply to the negative values. So also you can use 1 to add your data before applying the logarithmic transformation, to ensure that your value going to be positive. Another approach is binning. Suppose if we have the set of data values, then that set of data values, if you want to form as a group together, then you can apply the binning approach. For example, here I am having marks, student marks. Here whoever is having the range 0 to 30, all the people are categorizing into low class. Then whoever scored 31 to 70, that people are allotted into mid group. Then whoever scored 71 to 100, that people are grouped into high. So it can be viewed in the form of histogram. So this range 0 to 30 can be viewed like, suppose I'm having 25 people, so 25 people are, okay, 25 people are 0 to 30 range. Then middle, if I am having 10 people, so 31 to 70 I have like this. Second bin, the bin number 1, bin number 2. Then 71 to 100 I have 5 people, so like this. So this is bin number 3. So likewise we can make the given data points into some group of data points using binning method. Another one, this is for numerical values, and another one is categorical value. You look at that, here we are using the continent and here we are using the countries. So Spain is belonging to the Europe and Italy belonging to the Europe. So we can say like this, here 0 2 4 like this. So here first Europe continent and South America continent. In Europe continent we are having two countries. In South America we are having two countries. So bin number 1, bin number 2. So this is the way to create the binning. What it is doing, so which is doing the process of avoiding the overfitting, but there is the possibility of loss of granularity, that means loss of information of data. This grouping can be done using three different ways. We can use the equal intervals. You see here in this example we are not using the equal intervals. We are not using equal intervals. Suppose if you are using 0 to 25, 26 to 50, 51 to 75, 75 to 100. So this is the equal interval we are using to make the data points into groups. Then next one is equal frequencies. Equal frequencies, that means the number of observations in the particular bin. For each bin, suppose when you are drawing, so you look at this, here each bin is having two data. So this bin also having two data, this bin also having data, Europe, South America. So both are having two data. That is the thing. So each bin will have equal number of frequencies. Then next one is Here we are using the decision tree sorting. The decision tree will give you the classes which is sorted. So based upon that relationship, we will group into the given data points. Next one hot encoding. This is very important in machine learning model, which is encoding the categorical feature values into numerical feature values. That feature values will be the mostly zeros and ones. So this process should not lose any information that if affects the performance of model. So one hot encoding has to be used cautiously because that should not affect the performance of our model. It could result in dramatic increase in the number of features. Yes, when you are applying the one hot encoding, the number of features will increase, which resulting in the creation of highly correlated features. You look at this example. Here we are having feature number 1 candy variety, feature number 2 day, feature number 3 type of day. When you are applying the one hot encoding to feature number 3, I am going to apply the one hot encoding to feature number 3. So here this feature is having two different values: weekend, 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 weekend. So one type of value, weekday, weekday, second type of value. So here type of day is having two different values. These two different values will be transforming into the features. Look here, the weekend will become as one feature, weekday will become as another feature. Okay, once again I am repeating, the type of day feature is considered for one hot encoding. Type of the day is considered for one hot encoding. One hot encoding will use the values of these features, okay, values of these features as feature, as a feature. Here weekend is one value and weekday is another value. So weekend will be considered as one feature, weekday will be considered as another feature. So two values are acting as a features in the output feature set. So now you look at here, these values are same. So wherever weekend available, this is weekend available. So in that weekend we have to make as one. Yes, this is weekend, true, true value. True means we will add one. The weekend, yes, one. Is it weekday? No, zero. No means zero. Likewise, second data point, is it weekend? Yes, weekend. So we are making as 1. Is it weekday? No. So which is make as 0. Then third data point, weekday. Is it weekend? No. So make as 0. Is it weekend? Weekday? Yes, it is weekday. Third data, which is it weekend? Yes, which is weekend. Is it weekday? No, which is 0. Likewise, wherever that feature value is matching in the type of day, that will be make as a 1. If not matching, it will be 0. Other categorical encodings, here we may use count and number of times appearance. So that is also possible for label representation, and we may use mean value, and also we can use the ordinal encoding. Ordinal encoding means ascending order. Ascending order, we can use the numbers that is assigned to each unique label. We can assign the numbers to each categorical text value. That label will be unique. Then there is one more method, feature splitting. Here, if you want to split the feature value, then we can go for feature splitting, which will improve the value of our features. That means it will improve our model's performance. It will give you more depth knowledge about the data. So there you can use the feature splitting. Here, for example, date contributes more to the target function than date and time. Date and time will give with the time here. Date and time means here time may be 10 o'clock, 1 minute and 32 seconds. So instead of this entire value, only date will give you more information. So we are ignoring the time of that day. That is the meaning. So we are splitted. We have splitted date and time, and we ignoring the time. And second example here, this is name. Okay, this is the name. Name is having first name, middle name and surname. So here I don't want middle name and surname to my data set, so we can extract by using the split function. So wherever space is appearing, the space is considered as a splitting position. So wherever split is available, I can use right splitting. So I am splitting the only the first name. Okay, I am using first name, the remaining are ignoring. So this will improve our model performance sometimes. Then scaling in the sense, just we are changing the range of input values. The numerical features do not have certain range, that they're different from each other. That means here you look at that age. So here if I have age is one feature and income is another feature. So this is income. So age may be 25, income may be 2 lakhs per month, and age may be 50, income may be 50,000. 50,000. Age may be 30, income may be uh, 3 lakhs. Okay, so here the range of age and range of salary is entirely different range. Entirely different range. Here age is between 25 to 50, but the salary is from 50,000 to 3 lakhs. 3 lakhs. Okay, so when you are having different range, the computational power will increase and the performance of your model will decrease. Okay, so we cannot have different range. For solving this, we can apply the scaling approach. The scaling approach is used to uh, give the continuous features make into identical in terms of the range. The algorithms based on the distance calculations such as knn or k means need to have scaled continuous features as a model input, right? So it can be done two methods. One is the normalization and another one is standardization, z-score method. So the normalization is having x minus x minimum. Suppose I am having one feature is 25, 31, 2. Here if you have, this is the x value. For each x value we have to calculate. So 25 minus minimum of this feature value is 1 divided by x maximum is 30 minus minimum is 1, right? So when you are applying this, you will get 24 divided by 29, that will be your normalization value. So this will be applied to all the data points, then that data points range will become same scale. Then another one is standardization. Already we have discussed. We can apply the z-score. If you want to know again, you can view that handling outliers by using the z-score. So scaling is used to transforming the given data points range from large scale into same scale. With this, feature engineering technique is over. Thank you.